Welcome student, standard 10th, subject math second, unit trigonometry, unit number 6, trigonometry. In last year we study some basic concept which are trigonometric ratios and their identities. First we revise this concept, and in this unit we will study the trigonometrics, more identities and their applications. Student, we know trigonometry is a branch in a mathematics, is useful to find answers. So for example, the distance between ship and sea shore, the height of tree, means it is the useful branch of engineering, astronomy and navigation. Trigonometry means, here three words are given: trigonometrons, means tri means three, gon means sides and metron means measurements. In a right angle triangle, if three sides are given, then relation between their sides and acute angles, by using this we find the trigonometric ratios. First we study 6 trigonometric ratios, where which all trigonometric branch is depend. Now see here, in right angle triangle ABC, first we revise trigonometric ratios. There are 6 trigonometric ratios. In triangle ABC, angle C is acute angle, also angle A is acute angle. We mention angle C has theta, means theta measure. So AB is the opposite side of theta or angle C, and side BC is the adjacent side of angle C having measure theta. AC is the hypotenuse, side opposite to right angle. Now first trigonometric ratio is sine theta. What is the ratio of sine theta? It is the opposite side to the hypotenuse, means AB upon AC. Sine theta is the opposite side. This is the opposite side upon hypotenuse, means AB upon AC. Second trigonometric ratio is cos theta. It is the adjacent side to the hypotenuse, means BC upon AC. In word it is written as adjacent side upon hypotenuse. Third one, tan theta. Tan theta is the ratio of sides opposite to the adjacent, means AB upon BC gives opposite side upon adjacent side. Now there are three reciprocals of this: sine, cos and tan. Reciprocal of sine is cosec. Cosec theta is the ratio in which the reciprocal of sine, means hypotenuse upon opposite side. Hypotenuse upon opposite side means reciprocal of sine theta is AC upon AB. Sec theta is the reciprocal of cos, means hypotenuse upon adjacent side. Means AC upon BC. And cot theta is the reciprocal of tan, means adjacent side upon opposite side, means reciprocal of tan theta is BC upon AB. Now we form some trigonometric identities from this. Sine theta and cosec theta. These are the reciprocal of each other. So these are, we find first identity, sine theta is the reciprocal of cosec theta. By taking cross multiplication, we get sine theta into cosec theta. Sine theta into cosec theta, 1 into 1 means 1. The first identity, sine theta is the reciprocal of cosec theta, or cosec theta is equal to 1 upon sine theta. This is first. On the same manner, we can find cos theta is the reciprocal of sec theta. Tan theta is the reciprocal of cot theta, or cot theta is the reciprocal of tan theta. Also remember that, see here, by dividing AB upon AC, BC upon, if we take the division of sine theta to the cos theta, AC cancel, AB upon BC means we get tan theta. Tan theta is the ratio of, remember that, opposite side to the adjacent side. Opposite side to the adjacent sides. Opposite side to the adjacent side means we write as sine theta upon cos theta. This ratio gives tan theta, or cos theta upon sine theta gives cot theta. These are the some basic trigonometric identities. Now we see the trigonometric ratios of angles 0 degree, 30 degree, 45, 60 and 90. How can we remember this table for 0, 30, 45, 60 and 90 for these 6 trigonometric ratios? See the hint for this table. Remember 0 starting from 0. So here we write 0, then write 1, 2, 3 and 4. These 4 numbers 0 to 4. Write this number above the 0, 30, 45, 60, 90 degree angles. Then divide by 4 each. Divide by 4. Now we simplify here. 0 divided by 4 means 0. 1 upon 4, we write 1 upon 4. Here 2 ones are 2, 2 twos are 4. It is written as 1 by 2. Here no division, 3 upon 4. But here we divide 4 ones are 1, 4 ones are 1 means here 1. Now use this row to write down the sine angle for 0, 30, 45, 60 and 90. Means taking the, here we find these numbers. Now take the square root of each number. For example, square root of 0 is 0. Here square root of 1 by 4 means square root of 1 is 1, square root of 4 is 2. Here square root of 1 is 1, square root of 2 is root 2. Square root of 3 is root 3 and square root of 4 is 2. And square root of 1 is 1. These are the values for sine theta. Remember this. Remember 0, write down 0 to 4 number, 0, 1, 2, 3, 4. Divide by 4 each. By simplifying here and take the square root of and write the in particular column or bracket. Now these are the values for sine theta, sine angle. Now we find the values for cos angle. How can we write? First write down the last to first, then write the second, root 3 upon, then write 1 upon root 2, then write 1 upon 2, then write 0. Means these row write in the opposite to the respective values of cos. 1 root 3 by 2, 1 upon root 2, 1 by 2 and 0 in this way here. Now we remember tan theta is the ratio of, here we study sine upon cos, means sine theta upon cos theta gives tan theta. So we divide 0 by 1 means 0. 1 upon 2 divided by root 3 upon 2. 2 cancel. We write here 1 and root 3. both values same, so by dividing we get 1. Here root 3 by 2, 1 by 2, dividing 2 cancel, root 3 by 1 means 3, 1 upon 0 means it is not defined. Then write down the values of cosec. Cosec is the reciprocal of sine theta, so reciprocal of 0 is not defined. Reciprocal of 1 by 2 is 2, 1 upon root 2, reciprocal gives root 2. Here reciprocal 2 upon root 3, reciprocal of 1 is 1. Now the sec theta is the reciprocal of cos, means reciprocal of 1 is 1, here 2 upon root 3, here root 2, here 2, here reciprocal of 0 is not defined. Cot theta is the reciprocal of tan theta, so reciprocal of 0 is not defined. Reciprocal of 1 upon root 3 is root 3, reciprocal of 1 is 1, here its denominator is 1, therefore reciprocal of root 3 is 1 upon root 3, and reciprocal of not defined is 0. These are the values for trigonometric ratios of angle 0, 30, 45, 60 and 90. Now we see the basic fundamental trigonometric identities. First identity is sin square theta plus cos square theta is equal to 1. 1 plus cot square theta is equal to cosec square theta. 1 plus tan square theta is equal to sec square theta. We want to prove this. How can we prove this? Use right angle triangle PQR. Select one of the acute angle theta. Here this is opposite side, this is adjacent, this is opposite, and this is adjacent, this is hypotenuse. Now we first write down all trigonometric ratios. We have trigonometric ratios are first trigonometric ratio is sine theta, opposite upon hypotenuse means PQ upon PR. Cos theta is the ratio of adjacent to the hypotenuse, QR upon PR. And tan theta is the ratio of opposite to the adjacent, means PQ upon QR. Now then write down their reciprocals. Sine theta is the reciprocal of cosec theta. Cosec theta, its reciprocal is of sine theta, means PR upon PQ. Sec theta is the reciprocal of cos theta, means PR, its reciprocal PR upon QR. And cot theta is the reciprocal of tan theta, means QR upon PQ. Now use the Pythagoras theorem. By Pythagoras theorem, use here Pythagoras theorem. The square of hypotenuse is equal to sum of squares of remaining sides. PR square is equal to PQ square plus QR square. Now to prove these identities, sine square theta plus cos square theta is equal to 1, how can we solve this? Divide PR square on both sides, PR square, we get first identity. On dividing PQ square, we get second identity, and we dividing QR square on both sides of equation 1, we get identity number 3. Now we solve this. First write down given identity. Pythagoras identity, PQ square plus QR square is equal to PR square. On dividing both sides by PR square, PQ square upon PR square, QR square upon PR square, PR square upon PR square. Here both are cancelled, we get 1. PQ square upon PR square. See here, PQ upon PR means sine theta, that square means sine square theta. Here QR upon PR is the cos theta, so that square is cos square theta. So we prove the first identity. How can we prove this? First write down the Pythagoras theorem, dividing PR square on both sides and write down their respective identities. PQ upon PR means sine, QR upon PR means cos, and here square is given, therefore we write their respective squares. Now to prove the second, 1 plus cot square is equal to cosec square, we divide on both sides by PQ square upon PQ square on both sides, means each term is divided by PQ square. PQ square cancel. Here we get 1 plus QR upon PQ. QR upon PQ is a quad theta. Here QR upon PQ is quad theta, their square means quad square theta. PR upon PQ is the cosec, that square is cosec square theta. This is the second identity. And to prove the third identity, 1 plus tan square, divide on both sides of here by QR square. On dividing both sides of QR square, PQ square upon QR square upon QR square is equal to PR square upon QR square. These terms are cancelled. We get 1. PQ upon QR means here, see here, this is the tan theta, their square, tan square theta. PR upon QR is the sec theta is equal to sec square theta. Therefore 1 plus tan square is equal to sec square theta. These are the basic 3 fundamental identities we prove by using Pythagoras and trigonometric ratios.